Okay, we're going to take our, I guess it's our first real look at proofs. So I'm going to show you a proof, and then I'm going to ask you to sort of alter it a little bit to prove something slightly different. All right, so a couple comments about proofs. First, the standard format for most high school geometry proofs is what's called a two-column proof. So I have two columns. One is a list of statements, and for each statement there's a reason for why I know that that thing is true. Now your first couple of statements, or at least your very first statement, is pretty much always going to be given as your reason. What that means is that's the information that you started with. It was given to you. You were told something is true. Okay? And you don't question that. You just, okay, well, given that particular information, where do I go from there? A little bit of a delay there. Anyways, and then so from that given information, you are asked to prove something. What we mean by prove it is you're trying to take the information you're given. Well, if I knew that's true, then what else do I know is true? Right? Okay, so I can come up with some third thing that's true based on the information that I'm given, and maybe drawing in some other facts I know. And then, okay, maybe I can come up with a fourth thing that I know is true. Right? So, and maybe bringing in some facts from outside that I know to be true, and based on what's here. All right, so you're kind of a detective. You're piecing together a case here. Okay? In this particular case, the thing we're trying to prove is that angle BAC is equal to angle DAC. And a couple quick things about this statement here. First of all, this is technically inaccurate. Technically, we would say that angle BAC is congruent to angle DAC, and we would say that the measure of angle BAC is equal to the measure of angle DAC. Some proof writers will ignore this slight, kind of subtle difference here. The difference is for saying that two angles are congruent, right? That's a statement about the two angles. Here, what congruence means in terms of angles, congruence can mean all sorts of different things depending on segment lengths, or congruent triangles, or congruent angles. Congruent means different things. Specifically in the case of two angles, it means that their measures, the measure of angle BAC, is equal to the measure of angle DAC. And the very slight difference here is that measure of angle BAC is a number, and measure of angle DAC is a number. And if you're saying they're equal, you're saying that these two numbers are the same. That's slightly different from saying that the two angles are congruent, okay, but very slightly different. But you should be aware that some people will treat these as different statements. So sometimes you'll see angle BAC is congruent to angle DAC, and then right below it you'll see measure of BAC is equal to measure of DAC. And the reason for knowing that this is true is because it'll say definition of angle congruence. And just you're saying, well, what does it mean to be two angles are congruent? It means that they're the same measure, right? These two statements are almost interchangeable. Some proof writers will make us think about that, and others won't. Okay, so another thing about proofs is that although you're often given a diagram, what you're really basing it on is the information that you're given. So in this case, AB is equal to AD. So the distance from A to B, or the length of side AB, is the same as the length of side AD. And over here, BC is equal to DC. BC is equal to DC over here. We've got this diagram right here that kind of shows that. We've got this diagram over here that's slightly different, and we could say the same thing about this diagram. So these statements that the side AB and side AD are the same length, and that BC and DC are the same length, that's what we're really basing it on here, not on this specific diagram. So what our proof will apply to any diagram that would meet those requirements. Right? So what you've got to be careful of is you might look at the diagram and think, oh, that kind of looks like it's true, but if it's not stated as true and you haven't determined that it's true, it could just be a sort of a fluke of that particular diagram. Right? It might not be true of some other diagram. Okay, so let's take a look at this proof. What we're trying to prove here ultimately is that this angle right up here is the same size as that angle right there. Or I suppose on my little diagram, that these two angles are the same. And the kind of the overall method that we're going to use to get there is we're going to first prove that triangle ABC is the same as triangle ADC. Those two triangles are the same, that those two triangles are congruent. And then, based on that, we know that individual parts of those two triangles will also be congruent. So individual pairs of sides and angles will also be congruent. And we're going to say that angle BAC and DAC are corresponding parts of those two triangles. This is a pretty common approach for a lot of proofs. If I want to prove that a particular side matches some particular other side, or a particular angle matches some particular angle somewhere else, we might start by proving that two triangles are congruent. And the reason we're going to do that is because we've got information about side lengths, which is enough to show that the two triangles are congruent, but we don't know anything about angle measures. So we start with side lengths and move into angle measures. Okay. So we've got that AB and BC are equal to AD and DC. And we're going to add to that AC, right, is equal to AC. And our reason for that is going to be, now in the book, they call it shared side. Okay. Because if you look here, that triangle ABC and ADC both share this side. So we know that side AC for the triangle on the left is the same as side AC for the triangle on the right, because it's shared by both triangles. You'll also sometimes see reflexive property. Okay. Reflexive property is just this property that says that everything is the same as itself. Every number is equal to itself. And side AC is, this length AC is a number. Every length is equal to itself. Which seems kind of silly. Why do I have to say that? That's obvious. But the reason why I have to say that is because I need to have 3 pairs of corresponding sides being the same length in order to prove that the triangles are congruent. And so they all have to be listed here. Okay. So then I could say, based on all that, that triangle ABC is congruent to triangle ADC, right? So I've got one pair of corresponding congruent sides, another pair of corresponding congruent sides, a third pair of corresponding congruent sides, and by side, side, side congruence, that's enough to show that the two triangles are congruent. Yeah. And so then, based on that, right, we can then conclude, if the two triangles are congruent, that angle BAC is equal to angle DAC. Okay. So if these two triangles, right, ABC and ADC, if they're the same, if they're congruent, and they kind of are, you can see like they're reflections of each other, it folds over, then individual parts of those triangles must also be congruent. And of course, we already know that the sides are congruent because that was given information pretty much. But here our conclusion is about these two angles. These two angles must be the same because they are corresponding parts of the same corresponding parts of congruent triangles. And you'll also often see that abbreviated as corresponding parts of congruent triangles are congruent. It's a pretty common abbreviation you'll see in proofs. Corresponding parts of congruent triangles are congruent. So there. Now I've proven that those two angles are congruent. And again, our process was, well, we start out with our given information. We had to bring in an extra piece of information, right? And then based on that, we say, okay, well, we've got two congruent triangles. We've proven that because we know all the sides are congruent. And therefore, since all the sides are congruent, the other corresponding parts, which is the angles, that those are congruent, and specifically this angle right here. Now, technically, I'm just going to toss this in. We should say that the angles are congruent, not equal. Okay? And you might often see this add-on reason here, that measure of angle BAC equals measure of angle DAC, and our reason for that is definition of congruence. Okay, so we'd say, I've proven that the two angles are congruent because corresponding parts of congruent triangles are congruent, and therefore we know that the two angle measures are equal because that's what it means to be congruent. Okay. I suppose if we had corresponding parts of congruent triangles are equal in measure statement, then we could skip straight to this, but we don't have such a statement, which I suppose we could. Sort of silly. All right, so there we go. That's our proof. Now, up to you now is to use a similar proof to show that, let's see, oh yes, that angle ABC is congruent to angle DC. So that's your job. Also, we got this question here, right here. We've got that triangle ABC is congruent to triangle ADC, and why would it be improper to say that triangle ABC was congruent to triangle ACD? Why is that not good? Okay? So what's wrong with that? And then also, can you prove that these two angles here are congruent? Kind of using the same structure as what we've used here. Okay? All right, good luck.